we will solve this today's LeetCode problem. This is delete leaves with a given value. So it's a medium one, right? So let's see what it is. So we have a given a binary tree root and an integer target. Delete all the leaf nodes with value target. Note that once you delete a leaf node with a value target, if its parent node becomes a leaf node and has the value target, it should be also deleted. You need to continue doing until you cannot. Okay. So the one thing is here that we need to delete a root whose value is equal to target, and it should also be a leaf node, right? The thing is that one thing it's clear, it should be a leaf node. It should be leaf node, and its value should be equals to target, right? Equals to target. Second thing, that if after deleting the leaf node, if its parent also become a leaf node, then and if its value is also equals to target, then it's also need to be deleted, right? So we need to delete it again and again till we get a leaf node. We need to delete till I get a leaf node and its value equals to target, right? So we need to delete of every node, right? Each and every node after deleting it. So if you see the first example, here we have given target 2 and this is the tree given. So here if you see the leaf node, this is 2 and 2 is deleted, right? Because it's equals to target. After deleting this leftmost tree, its parent also become a leaf node. So and its value target is 2. So it should be also deleted, right? So it should be also deleted. But after this 2, its parent is not a leaf node and neither its value is equal to target. So we don't delete it, this 3, this 4 and this 1. So 1, 3, 4 will be left, right? Again, if you see in this example, this is target 3. So leaf node is this and this should be deleted. After this this its parent root is target is value is 3, root value is equals to target, but it is not a leaf node. And that's because this 2 is not deleted, so we will not delete it, so it will left it 132. So, right. So if you see here, uh, what we need to do, we need to traverse we need to we need to traverse till the leaf node. We need to anyhow traverse till the leaf node, till the leaf node. And if it is its value is equals to target, equals to target, we need to delete it. We need to delete it, right? So this is for sure. If we need to traverse to leaf node and if its value equals target, then we need to delete it. But what we do when we delete it and how we check this parent? So when we come back, when we come back after deleting this, after deleting the leaf node, we will check its parent again, that that whether it is a leaf node or not, because it may be possible na कि मैं leaf node we delete the leaf node and we after deleting the leaf node the parent becomes leaf node again and its value is and we also check that parents again we leaf node, and we also check that its value equals to target or not, equals to target or not, right? This both should be checked. So if it is, then we will also need to delete it. And if it is, and if all the conditions satisfies, if all the conditions satisfy, then we will delete it simply, right? So for traversal, how we will traverse? So if you have solved the previous problem and or previous, that was what, that was pre-order traversal, right? That was pre-order traversal. we will move in this direction 1, 2, and this is 2, right? And now we will move to this 3, 3. It's very hard to make a graph using your keyboard, and this is 2, right? So it's helpful if you have practice on like this, because it's will be helpful on interviews purpose if they ask you a tree problem, right? So yeah, so this is 1 2 3 4. So this value, we will move from 1 to this leaf node 2. This is the leaf node, we delete it, and we return a null to this 2. So this become nulls, this become null, right? After this, when we comes to this parent, after going to this null to this, when we go to parent, its left value is null, its right value is null, and its value is target. So we'll again return null from here to its one parent, right? After returning one, it will go to right, move to its right, right? So it will goes to 3, then it will go to its left 2. So it 2 value is again target value, and it is also leaf node, so we will delete it. After deleting this, 3's left value is null, but right value is 4, and it is also not a leaf node. And so the one thing is clear: it is not a leaf node, so its parent will also be it's not it will not be deleted. So one is also not to be deleted. So the we have left a value with 1, 1, 3, and of course 4, right? And of course 4, right? So this is the answer we get after this, right? So this is how we will move. So let's implement this, right? Let's see if just return the solve function. Yeah. Let's make a solve function and pass this root and this target. This will be a tree node. This is the solve and target. Let's see. Uh, one thing is clear that if I got a leaf node, I need to check the value. So first thing is I will see leaf node. If it is a leaf node, then I will simply check that whether its value is equal to target or not. If it is, then I will just return null. If it is, I will just return null, right? Because its value is target, so I need to delete it. So I need to return the null value, and if it is not, then I will return the root. It's simple, right? Now I need to check for the left part. I will move to its left part and this target value. Why root to left? Because when I return null, it will assign to my root left. So this is a parent, and after calling its child, it will give me null value if it's not it's equals to target. So roots left will be equals to null. Same thing goes with right value, right? Same thing goes with right value. That will be target. And now I will check again that whether my parent is null and its value is equals to target. Then I will again return null. Simply what we have done, I go to its left, then its right, and see that whether we have get a null value or not, and assign to that left value, right? And check again that this root's value is again leaf or not, and its value is target or not. If it is, then we again return null, because this should be deleted, and otherwise I will leave this again and return root simply, right? So this is the this should be the problem. Okay, one thing is here, that what if this root left is null? So this will give me an error because I'm accessing it, right? So I need to also check that this should be not null, and we will return null here. So let's run this. This should be working. Something is fishy. Okay, okay. I have not written root here. Okay, yeah. Let's run this again. Okay, yeah. We have passed this test case. Let's submit it. Yeah, we have successfully passed the test cases. So if you see here, so one thing while implementing this, one thing I observed here, that this thing and this thing is similar. Don't you think? Right? This thing and this thing is similar. So instead of going, instead of writing this, if I remove this and check this thing is here, still write this here. I write this here in this part. So don't you think I will be uh, okay? So if I see this here, so I think this should be checked. This can be checked here for simplification. If this root is, then we will return simply null. Otherwise, we can return this root. This is the same thing which I have written here, right? If the root value is target, and we will return null. Otherwise, we will untouch this. So this is the best case which we have handled. It's just the simplification part. You have we have write this like this. We just call root left, root right, and if I get a leaf node, so if we have a leaf node, then this root left will be null, root right will be null, right? And so this is null, and this value is target, so it again return null, right? This is the same thing. After removing this, it is already handling the leaf node condition, so we don't need this, right? It is again handling this condition, so we don't need this. Let's run this. Let's see if it is working. Yeah, I think this should work. Yeah, it's working. Let's submit it. Yeah, this is working. So so this is very much simplification code. Right? So because this is just like we have reduced this all the lines. So let's discuss the time and the space complexity. Time complexity will be O of n because I need to move in for every node, and the space complexity will be the auxiliary time complexity. Space complexity will be O of 1 again. But here's a recursion stack space, which we O of n, right? Right. So this is how we will solve the problem. So overall, this space complexity will be O of n, right? I hope you have already solved this problem because this is something pre-order traversal and it's just a previous one problem. So if you have not solved the previous problem, I suggest you to solve yesterday's problem, then comes to this, right? Uh, yeah, thank you so much. Bye bye.